What you are seeing right now is a nozzle which basically gives laminar flow into the atmosphere, right? So there's a pipe from which there's water coming out, and it's coming through the nozzle, and that nozzle is going to provide a laminar flow. So sometimes it cannot provide a laminar flow, and then this thing happens, so it spreads out and it kind of sprays, and then there's small holes in the cross sectional. So the actual area is still A2, but that's going to be the apparent area minus the holes. So over here, as V is fixed, A2 is fixed, and A1 is fixed for the nozzle and the speed of the water required, right? The one which we require. So using the Bernoulli's equation, we can get P, which is the pressure in the pipe, as some fixed value which is decided by A1, A2 and V, right? So basically U is also decided by V, A1 and A2. So in that case, P is in fact decided directly by A1, A2 and V. Okay, so for this cylindrical nozzle, turns out that the value of that pressure which is going to give the laminar flow, that's going to be 0, right? So if the pressure is more than 0, which means it's positive, which it generally is, in that case this is going to get sprayed out. So that's why it's actually incorrect to assume that orifices on the containers are like cylindrical or something, because then you are ignoring the equation of continuity. So you should always assume that the orifice is something like this, which has two areas, such that it's still continuous, the flow is still laminar. And yes, you can still use A2 as the area in this case for the equation of continuity. So yeah, that still kind of works, but not always, right? So yeah, fine. Okay, so I will see you in the next video.